As human beings, we tend to take pride in our intelligence and curiosity. We've built civilizations, solved complex problems, and explored the depths of our planet. However, when it comes to understanding the universe, the grandest and most mysterious stage of all, we've only just begun to scratch the surface. The cosmos is staggeringly vast, with an age estimated at about 13.8 billion years, and it is still expanding at accelerating rates. This expansion gives rise to one of the most profound questions in all of science. What came before the universe? Began? What ignited the Big Bang? These questions strike at the very foundation of existence and remain some of the deepest mysteries science has ever faced. Despite the fact that we can't directly observe the moment the universe began, scientists have been relentlessly trying to unravel the events that occurred during those first moments. Though we lack the ability to view it with our own eyes, our understanding of the universe's beginnings is shaped by powerful theories, advanced simulations, and crucial indirect evidence. One such theory, the Big Bang theory, remains the leading explanation for how everything we know came into being. The Big Bang theory proposes that the universe originated from an unimaginably hot, dense singularity, a point where space and time were compressed to infinite degrees. From this singularity, in a sudden and explosive moment, the universe began expanding at incredible speed. This rapid inflation happened in a fraction of a second and has continued over billions of years, although at a slower rate. From that tiny chaotic starting point arose all matter, energy, space, and time. Everything that exists, every star, every galaxy, even the very fabric of reality, evolved from this moment. But even though this theory is widely accepted, there's a major limitation. We cannot observe the Big Bang directly. Our insights come instead from mathematical equations, cosmological models, and indirect observational evidence collected over decades. Among the most important of these is the cosmic microwave background radiation, CMB, a faint glow that permeates the universe. This residual radiation is thought to be the oldest light in existence, a fossil of the Big Bang itself. It was first predicted in 1948 by physicists trying to understand how the universe cooled after its birth, and it was accidentally discovered in 1965. Since then, the CMB has served as a cornerstone for cosmological research, helping scientists learn about the universe's age, composition, and early structure. Yet even with this key piece of evidence, many details about the origin of the universe remain hidden. To peer deeper into the past, humanity has built increasingly advanced telescopes. Most recently, the James Webb Space Telescope, JWST, has emerged as our most powerful tool for cosmic exploration. Unlike the famous Hubble Space Telescope, which observes mostly in the visible and ultraviolet parts of the electromagnetic spectrum, JWST is specifically designed to detect infrared light. This is a crucial difference because as the universe expands, light from ancient galaxies becomes stretched, shifting from visible wavelengths into the infrared. This phenomenon, known as redshift, means that many of the earliest galaxies in the universe can only be detected through infrared observation. In this sense, the James Webb Space Telescope acts as a kind of time machine, allowing scientists to see back in time by detecting light that has traveled for billions of years. It provides a view of the universe not as it is now, but as it was shortly after it began. This ability marks a revolutionary step forward in our efforts to understand the universe's formation and evolution. The telescope's first major achievement came on July 12, 2022, when it released its first full-color images. These images captured intricate and dazzling views of cosmic features like the Carina Nebula, the interacting galaxies of Stephan's Quintet, and deep-field views showing countless ancient galaxies. These snapshots of the cosmos were not just beautiful, they were scientifically groundbreaking. Shortly after these images were made public, the telescope achieved a milestone, the detection of the oldest galaxy ever observed. This galaxy is believed to have formed just 300 million years after the Big Bang. While that may seem like a long time, on a cosmic timescale, it's practically at the dawn of existence. What allows the James Webb Space Telescope to accomplish Such feats is not just its ability to detect infrared light, but also its strategic placement and sophisticated engineering. It resides at a location in space known as Lagrange Point 2, L2, a stable point in the gravitational balance between the Earth and the Sun, located about 1.5 million kilometers from Earth. This positioning ensures the telescope remains in a stable orbit, shielded from Earth's light and heat, which could interfere with its delicate observations. Compared to Hubble, which orbits just 570 kilometers above Earth, this distance represents a monumental leap in terms of stability and observational clarity. JWST also boasts a 6.5-meter gold-coated primary mirror, composed of 18 hexagonal segments, designed to collect and focus extremely faint light. A 22-meter sunshield protects it from solar radiation, keeping its instruments cool and functional. This design makes it the most advanced space telescope ever built, capable of observing some of the faintest and most distant objects in the cosmos. So what truly sets JWST apart from Hubble and other telescopes? One key distinction is light gathering power. Its larger mirror collects over 6 times more light than Hubble's 2.4-meter mirror, enabling it to detect far fainter objects and reveal much more detail. With this capability, JWST is not only observing ancient galaxies, but also revolutionizing our understanding of exoplanets, black holes, star formation, and dark matter. Among the most astonishing discoveries made so far was the identification of 6 enormous galaxies that existed a mere 500 to 700 million years after the Big Bang. These galaxies appeared to be far larger and more developed than theoretical models had predicted for such an early time. In fact, some of them may be as massive as the Milky Way. According to current understanding, the early universe was too unstable and chaotic for such large structures to form so quickly. This unexpected finding has forced scientists to reconsider how galaxies form and evolve. If these results are confirmed, it could imply that galaxies formed earlier and more efficiently than we had ever imagined, possibly requiring us to rewrite the cosmic timeline altogether. But the telescope's mission doesn't stop at distant galaxies. It is also opening entirely new doors in the field of planetary science. Within just its first few months of operation, JWST was able to study the atmosphere of the exoplanet WASP-96b, identifying signatures of water vapor, clouds, and even chemical compounds. These findings are especially important in the ongoing search for life beyond Earth. By analyzing the atmospheres of distant planets, we can begin to assess their habitability, their climate, and even their potential to support life. In summary, the James Webb Space Telescope is proving to be a true game-changer for astronomy and cosmology. Every new discovery challenges long-held assumptions, prompts new questions, and pushes the boundaries of what we thought was possible. With each image and data set it returns, it is helping to paint a clearer picture of our universe's past, present, and future. What lies ahead? Could the telescope eventually detect the very first stars that ignited after the Big Bang? Might it shed light on the formation of black holes, or even offer insight into the mysterious realm of dark energy? Could it provide hints about what, if anything, existed before the Big Bang? Only time will tell. But one thing is certain: with this powerful observatory at work, we are entering a new era of cosmic discovery, one that could forever transform our place in the universe.